So in the previous video, we talked about all of these translations, all of the transformations it could undergo. Those are rules you have to have memorized. No, you do not get a note card. Okay, then most teachers teach that you need a parent function. Okay, the parent function is whatever we graph originally, whether that is some weird wacko shape called f of x, or it's an absolute value that makes a v-graph, or it is an exponential that is a j-curve, or it's a line that moves upwards or downwards, but we'll probably just use y equals mx plus b to graph that. Or a U-shaped graph, like a quadratic. Okay, there's a lot of different things that we can draw. Then we go by these orders of H, S, R, V, except most teachers teach it that way. I just teach it through PEMDAS. I'm like, it makes more sense that we go parentheses first. There's almost never any exponents. Then we look at the multiplications and the divisions and the additions and subtractions that are not in parentheses. So when we flip to our next page, we start to go in order. Okay. So number 1 on our next page has this guy, which does a +1. It says, please put your transformations in words. The words are meant to help you. They are meant to be a good thing. So as I go +1 on the outside, this is an up, because on outside it's up and down. I talk about how if you dig in the dirt outside or if you jump up and down outside, nobody really gets mad at you, but if you do that inside, you might get yelled at. So everything moves up just 1, and I connect all of those pieces together. This gives me a similar graph that moved upwards 1. Right here, I have a +1 on the inside, a -2 on the outside. By PEMDAS, I have to do that one on the inside first. Right now, it's not going to make a difference the order, but I promise you it does later. So my PEMDAS, I'm going to move up 1. I'm going to move up 1. I lied. My PEMDAS, I'm on the inside. I'm going to move left and right. I'm going to move left 1 because I'm in a mirror. So that mirror caused me to move the opposite of what you think. I redraw my piece. And it looks like that. Okay. So then I'm going to take my down 2. That was on the outside. And I'm going to move this new graph down 2. It's important that we're moving the new graph and not the old graph. So I end up with a graph that looks very similar, just shifted downwards 2 and left 1. It is important the order that you go in. It gets more important as we move forward. Okay. So here, I've told you that we are not going to do anything on the inside. We're not going to do any of these horizontal shifts, the shrinks and the stretches. That's very difficult for people. So we move it to the outside. On the outside, this is going to cause my graph to look short and fat. I have that rule memorized. It is a shrink. What I'm going to do is I'm going to double check at the end that it does look shorter and fatter. That's how I know whether I got it right or not. Because it's on the outside, it's dealing with my up and down. This moved up and down 0. So since it moved up and down 0, I'm going to multiply that by 1/2 to end up with a 0. That dot will not move. That is why it becomes important what order we do things in. This dot right here was up 2. I'm going to multiply that by 1/2. I end up 1. So as you can see, it got short, and I get the illusion of being fatter. Okay. This one was down 1 or a negative 1 times 1/2. This gives me a down 1/2. Sorry, it was down 2. This gives me a down 1, or it was negative 2 times 1/2, which gives me a negative 1. That will move me to here. Again, it gives the illusion of being shorter and fatter because you still haven't like lost any weight. You're still as far wide as you are. This one is at 0, just like the other one was. We keep it there. Here, as I read this, I'm going to go by PEMDAS. There's nothing in the parentheses. There is a multiplication, though. That multiplication is of a negative. The negative is on the outside. This is going to cause a shift up and down. It is a flip. Okay, so that flip happens over this x-axis. That x-axis becomes my mirror. If I touch a mirror, my finger will touch the mirror and I won't be able to see the other side of my finger. So it goes right there. If I'm 2 away from a mirror, I'm going to see myself 2 away from the mirror on the other side. Again, if I see myself 2 away from a mirror, I'm going to see myself 2 away from the mirror on the other side. And if I touch a mirror, I will cover up my finger and I will not be able to see any piece of it. I get the same shape flipped upside down. From there, I need to go down 1. This is one of the ones that if you did it wrong, it will look different. Please make sure that you double check your answers, that you have checked to make sure that you did this correctly, because it will look very different if you did it in a different order. This is one of the ones that PEMDAS is really, really super important on. Right here. Again, we're going to get rid of this inside number and we'll move it to the outside so that we get practice with the stretches on the outside. This is going to be a stretch. It's going to look tall and skinny. I'm going to take my y's and I'm going to multiply them by 2. Okay? But I should do the inside of this first because that's in parentheses. So I'm actually going to do my flippity flip first. My flip happens going left and right because it happens on the inside. It flips over the y-axis. So this point was to this way. It's now going to go to that way. This point was to this way. It's now going to go to that way. And these points do a straight up switch. I end up with this graph. Sorry, I misplaced. I end up with this graph. So then I need to stretch it. This one was at a 0 up and down. I multiply by 2, I still get a 0. That will stay right there. Same with that point, it's at a 0, it's going to stay right there. This point, because this is the point I'm moving now, was down 2 or negative 2. I'm going to multiply by 2 and I get down 4 or I get a negative 4. It's important that we are coming from the line, from the x-axis, not from the point. So it is down 4 from the line. That's how this one stretches. This one was up 2 from the line. I multiply by 2, I get an up 4 movement. I go and I draw my lines, and I get a taller and skinnier graph that flipped over my y-axis. It flipped left and right. Okay. So here, I look at my parentheses first. In my parentheses, I get a +2. Since it's in parentheses, it's happening in a mirror. It's going the opposite direction. I move 2 over. I draw it. Okay. From there, I've done this. I now need to do this outside one, the multiply by 2. So my 0 is going to stay the same. My 0 is going to stay the same. My -2 becomes a -4, and it jumps that way. My +2 becomes a +4, and it jumps that way. I get something that looks tall and skinny. Okay. Now I take my third color. Okay. My third color is going to move this down 1. My other green stretched, tall, skinny, multiply y by 2. Okay, I'm going to use a star as my multiply instead. So now I'm going to move down 1, down 1, down 1, down 1. This is a graph that would have looked different if you had done it in a different order. Please double check your graph and make sure that yours looks like mine. That is the end of that page, okay? This page we completely did in class. All we did was really talk about how the absolute value graph looks like a V that goes up 1 over 1. So I'm going to do some absolute value transformations in the next video.